In this video, we are going to discuss about flow control. In flow control, we will have stop and wait ARQ, go back N, and selective repeat. So let's go. Flow control are majorly divided into two types: noiseless channels and noisy channels. In noisy channels, you will have some lost in acknowledgements and lost in frames like that. In noiseless channels, you won't have any kind of errors or any kind of lostness. Okay. There are two types of noiseless channels. One is simplest protocol and stop and wait protocol. In simplest protocol, if we have a request, then we will have a rival. If we has a request, it will have a rival. It's simple and it is not that much important. So I'm hurrying it up. So stop and wait protocol. If you have a request, then it will have acknowledgement, and if you have a request, it will have acknowledgement. It is a stop and wait protocol. In noiseless channel, there will be stop and wait protocol in noisy channel. Now let's see what it is. If you have a frame and it has a acknowledgement, it started and stopped here. Let's say if a frame is sent and it is lost somewhere, so it will have some timeout. So it doesn't got any acknowledgement. It will wait for some time for acknowledgement. So frame 1 is resented again. If then it received acknowledgement, then only it will go for another frame. So frame 0 is went and got its acknowledgement, and then frame 1 started. If it is lost, it will wait for some time, and again it's resend the frame 1, and then it will receive the acknowledgement. Let's say if frame 0 is sent and its acknowledgement is lost, so it will wait for some time for the acknowledgement of f0. There is no acknowledgement of f0, so f0 will be resented until it gets the acknowledgement. This is stop and wait ARQ. So sender side window is 1 and receiver side window is 1. So efficiency formula is 1 by 1 plus 2x, where x equals to propagation delay by transmission delay. Propagation delay is formula is distance by propagation speed. The transmission delay formula is packet size by bandwidth. This is another type of utilization or efficiency formula, RT by RT plus RTT, where RTT is equals to round trip, that is 2 into propagation delay, and there will be one another formula, bandwidth delay product, that is round trip into bandwidth, that is 2 times of propagation delay into bandwidth. Efficiency is equals to throughput by bandwidth, therefore throughput equals to efficiency into bandwidth. This is all about stop and wait ARQ. Now I will discuss about go back. In go back and ARQ, in the center side window will be 2 power k minus 1, where these all frames will be sent at a time. So let's see what is go back in ARQ. Frame 0, frame 1, frame 2, frame 3 are sent at a time. So irrespective to their acknowledgements, frame 0 is sent, acknowledgement 1 is received, frame 1 is lost. It doesn't matter for frame 2. Frame 2 will be going on and frame 3 will be going on. Receiver receives but discards. Frame 3 also receives but discards, and frame 1 is resent, acknowledgement received, and frame 2 is resent, acknowledgement received, and frame 3 is resent, acknowledgement is received. Frame 1 is sent, frame 1 is resent. Even though frame 2 and frame 3 went, it receives S but discards. B receives, so let's say it is A, it is B. B receives but discards. So frame 1 is resented again acknowledgement, frame 2 is resented again, and again acknowledgement, and frame 3 is resented again. It can be represented as this, or this is also correct, because frame 1, frame 2, frame 3 are will be resented at a time again, and acknowledgement also will be received at a time again. So formula for efficiency is 2 power k minus 1 into 1 by 2 plus x, where k represents number of bits. If k is equals to 2, then bits possible bits are 0, 1, 2, 3. Okay, like that. Where x equals to tp by tt. This is go back in protocol. Now let's see selective repeat. It is same. Now let's see selective repeat. It is same like go back and protocol. If the frame 1 is sent, acknowledgement is received. If frame 1 is lost, here frame 2 will be received. B receives frame 2, but it sends the negative acknowledgement. You should remember this word, negative acknowledgement. Frame 2 will be received and it sends negative acknowledgement, where we don't have this kind of technology in go back and ARQ and or in stop and wait. After receiving this negative acknowledgement, it says frame 1 is lost somewhere. This negative acknowledgement says frame 1 is lost somewhere in the channel. I did not receive frame 1. How can I receive frame 2? So after receiving this negative acknowledgement, immediately the sender sends frame 1. Then if it is resented properly, acknowledgement will be received, and then F2 will be resended, and then F3 will be resended. Hope you understand here. If not, go back and rewatch it again. Sender window is 2 power k minus 1 and receiver window is 2 power k minus 1, where here will be 2 power k minus 1 here 2 power k minus 1, okay. So efficiency formula will be 2 power k minus 1 into 1 by 1 plus 2x, where k is equals to number of bits and x we know TP by TT, propagation delay by transmission delay. Thank you.